Welcome to Design30. My name is Jason Bilyeu, and in this podcast, I discuss strategies and tools to improve creativity, innovation, and overall design confidence. Okay, to start, a few things, just going to rattle off a little bit of housekeeping. Please follow Design30 on YouTube, Instagram, Substack, or look it up on Patreon if you are interested in more content or in supporting the podcast. The topic of today's episode is factor of safety. So the formal definition of factor of safety, or you might hear it safety factor, either way works. The definition is the use of more elements than is thought to be necessary to offset the effects of unknown variables and prevent system failure. This definition was taken from the Universal Principles of Design, and I think it's a really good way of describing it, especially in the context of design. I think people often look at safety factor or a factor of safety as a purely engineering, maybe structural engineering, mechanical engineering sort of thing, but it really can be applied in a lot of different ways. Obviously, it is incredibly important in mechanical engineering, structural engineering, because people's lives are often on the line. So you don't want the people designing your airplanes to not take into account a safety factor. But it can also be applied in a lot of other ways. A good start, though, is just to have a better understanding of what it is and when to use it, when it's necessary to use it, and how to use it well. So to start, I'm going to describe this essentially a graph looking at your factor of safety on your y-axis and your ignorance, or maybe a better word would be your uncertainty about your design or how it will be used on the x-axis. So again, a factor of safety it's these elements in a design that are implemented in abundance or more than necessary so that you can offset the effects of unknown variables. And this is all in an attempt to prevent system failures. So again, picture this chart or this graph in your mind with your factor of safety on your y-axis and your uncertainty on the x-axis. So what should happen ideally is as your ignorance or your uncertainty increases, you also need to scale your factor of safety with that. So you can picture this as a linear line going at a 45-degree angle between your x and y axes. If we cut this graph up into 4 quadrants, you can think of the top right quadrant where you have high uncertainty as well as a large factor of safety as a prohibitively expensive area. This is somewhere where you want to stay out of. It's essentially something where your uncertainty is so high that the factor of safety required to make it a viable product or maybe even just a safe product, it's so over-designed, requires so much over-engineering and time, that's just going to be way too expensive to actually design this product. And then if you look at the bottom right quadrant, this is where you have high uncertainty, but a low factor of safety. And this is just something that's likely to fail. There's too many variables, too many unknowns, and you're not taking them into account with a factor of safety. So your design is most likely going to fail. And then in the top left quadrant, we have a place where your factor of safety is really high, but you also have low uncertainty. So this is something where you don't have that many unknowns. You seem to understand either your users or the application really well, but you've essentially over-engineered it. You've put a lot of time and money into this factor of safety. So this quadrant I've named a waste of money. You're putting too much time into over-engineering your product. The place where you want to be is the lower left quadrant. So this is where your uncertainty and your factor of safety both scale together, but you haven't gotten to that point where there's so much uncertainty and you have to have such a high factor of safety that you're getting into that region of prohibitively expensive design. So this bottom left quadrant is really where you want to be. And if you think of what a theoretically perfect design would be, this would be right where your X and Y axis start. So where you have zero uncertainty, you know everything you possibly need to know, and therefore you don't have to have a factor of safety. And this is the 0 point because, and I'm also calling it a theoretically perfect design because it's not actually possible. You're never going to be in a situation where you don't have any uncertainty whatsoever. To help drive this point home about the factor of safety, I want to go through a few examples. And the first one is in website design. So you want to implement a factor of safety when thinking about the number of users or your expected number of users on the website. And you want to design your website to be able to handle something more than that. So your factor of safety would be the number of people that your website is designed to handle, how much traffic it's designed to handle, and you would divide that by the number of people you actually expect. So a good factor of safety in this case might be 2 or 4, which essentially means that you're designing your website to handle 4 times the traffic than you actually expect. And this is just to prevent any sort of failure when you're perhaps launching a new website. If you have low confidence in your expected number of users, then you're going to want to increase this factor of safety. Again, those two need to scale together. The less certainty or the more uncertainty you have, you also need to increase your factor of safety. Another example is in mechanical engineering. So let's look at a bolt, for example, that has a shear force acting on it. So for people who aren't familiar, a shear force on a bolt is essentially, you can think of it as having 2 plates bolted together and then a force pushing those 2 plates to slide across each other. And if the bolt shears, that means it actually just breaks the bolt essentially and allows the 2 plates to slide past each other. So when you're designing this, you need to think about how much shear force you expect your bolt to be impacted by or to have to endure. And then you need to think about how much shear force it's physically capable of taking. So your factor of safety here is the force of failure, at what point your bolt is going to shear, and you divide that by the force that you believe will be allowed or that it'll actually run into when it's being used in whatever application it's being used in. So this ratio is your factor of safety. So looking at the factor of safety over time, over the whole product life cycle, it's kind of an interesting way to look at it. Because early on in the design process or for new designs, you typically want to have a larger factor of safety because you don't know exactly how it's going to be used. Maybe you don't know how many users are going to be on your website or on your app. There's a lot of uncertainty early on or with new designs. And so this leads to a necessity of having a large safety factor. If you don't want your product to fail, you need to take this into account. You have to scale that safety factor with the uncertainty associated with your design. And then as the design matures over time, and you have a better understanding of the use cases, a better understanding of what the average number of users is going to be, then you can actually start scaling that safety factor back. If you keep producing this product and you can go through some cost reduction designs or processes and actually remove some cost out of that because you can have a lower factor of safety. And this can be taken to an extreme, as can all things. And sometimes you get so into your cost reductions that you reduce this factor of safety so much that you end up having a failure. And hopefully it's not catastrophic, but it could be. It's definitely happened in the past with a lot of companies. It's very tempting to reduce costs and increase profits. But at that point, once you have that failure, you'll often see this factor of safety increased once again to prevent that from hopefully ever happening again. So the takeaways for this episode on the factor of safety are fairly simple, but I think they're important to keep in mind. First of all, as uncertainty increases, so should your factor of safety. And if uncertainty is reduced, then you can have a lower factor of safety. If you have too many unknown variables, this can lead to a prohibitively expensive design due to the large factor of safety that will result from this large uncertainty. And there's a lot of different sources of uncertainty in the world of design. Obviously, it depends very much on what field you're working in. But this uncertainty can come from variations in material properties, especially for people working in mechanical engineering, structural engineering, civil engineering, things like that. It can also stem from a lack of user research. User research can often be very expensive or time intensive. So sometimes there's uncertainty associated with that. You just don't have the time or money to gain all the information you need to gain. So you have to build in this factor of safety to account for that. Related to that, there can also be a lack of understanding of your market size or your potential number of users. And again, this will often come from lack of money or time. Maybe you don't have the expertise to gain a decent understanding of what the size will be. So you're not very confident in your market analysis. That's a situation where you're going to need to increase your factor of safety to avoid failures when you release the product. And that's about it for this shorter episode on factors of safety. The design discipline for this week is just 2 points. First of all, scale your factor of safety with uncertainty. Pretty basic, but keep that in mind. And lastly, reduce your factor of safety with caution and with information. Only do it when you have more certainty about your product, about the users, about the environment in which it's going to be used, things like that. And that is where I will leave it for this episode. As always, design more, despair less. Thanks for listening.